He has never served in the armed forces, nor does he have any military training.
Just the man I'm looking for.
Who?
Yeah, you.
I didn't do it.
I know you didn't.
I didn't eat those jelly beans.
I know you didn't eat the jelly beans. Listen to this. I want to ask your opinion about something.
You came to the right man. I am full of opinions. I have so many opinions. My head, there isn't room for anything else in it.
That's very good, because this is what I want to ask you. I'm thinking of going into the candy business, and I don't know what size candy bar I should sell. Now, should I sell one that is 10 centimeters by 10 centimeters by 1 centimeter, or one that is 5 centimeters by 20 centimeters by 1 centimeter, or one that is 2 centimeters by 25 centimeters by 2 centimeters? Now, which one of these would you buy?
None of them.
None of them?
They all look like they're made of wood.
They are made of wood.
These are wood?
Yeah, they're made of wood.
Bye.
Wait a second. These are just dummies.
And anybody who wants to buy a wooden candy bar has to be a dummy also.
That's very funny, very funny. Let me put it to you another way. If these really were candy bars, which one would you buy?
How much do they cost?
They're all the same.
They all cost the same?
Yeah, they all cost the same.
Then I'd buy the biggest one.
Aha! The biggest one. Which one is the biggest one?
This is the biggest one.
This is the biggest one. What if I told you that these were all the same size?
Bye!
Wait a minute. Where are you going?
One of us isn't well.
What do you mean?
I mean, first you ask me to buy a wooden candy bar, then you tell me they're all the same size.
They are all the same size. In fact, they're all the same volume, and I can prove it. Pay attention here. Now, this one here is 10 centimeters by 10 centimeters by 1 centimeter, okay? Now, we know that length times width times depth gives us volume, right? In this case, 10 times 10 times 1, 100 cubic centimeters, right?
100 cubic centimeters.
Very good. Okay, this one, 5 by 20 by 1. Also, 100 cubic centimeters. Yeah? This one here is 2 by 25 by 2. Also,
100 cubic centimeters.
You're very smart. They all have the same volume. They all have the same amount of chocolate. Now, knowing that they all have the same amount of chocolate, which one would you buy? What do you say?
I say I still wouldn't want to eat a wooden candy bar. I'd be afraid of splinters. Bye.
Send the car tomorrow, Phil. No, I can't leave now. I'm on the verge of a really big story. Well, no, but... Ooh, gotta go. There's my cue.
The trees being cut down are special. Rangers have figured out their width and height, and now it's up to lumberjacks to cut the trees into logs and get them to the right place. Like Monson, Maine, home of Moosehead Manufacturing. The people here use the wood in the logs to make furniture.
I'm here with Bob Brown, who's worked at Moosehead for 28 years. Bob, what's the first thing you do here after the logs are delivered?
To find the number of board feet contained in the log.
Board feet? What are they?
It's the unit of measurement of wood that's contained in the log.
Oh, well, what does a board that has the volume of a board foot look like?
This is a board foot, 1 inch thick, 12 inches wide, and 12 inches long.
Oh, boards of different lengths, widths, and thicknesses can all have the volume of 1 board foot. These other 2 examples have different dimensions, but also have the volume of 1 board foot.
Let's make it easy and look at this log.
Okay.
It's 1 foot long, and it's approximately 1 foot wide, and we need to know how many board feet we can get from this log.
Oh, well, that's easy. We can get 2 boards that measure 1 inch thick by 12 inches or a foot wide by a foot long from this middle part. Now, that's 2 board feet.
but we still have to deal with the curved part of the log. Suppose Bob cut the log into 12 boards. We want to find the total volume of the boards in the log. To find the volume of one of these boards, we would multiply its length by its width by its thickness. Each of these boards is 1 foot long and 1 inch thick. All we have to do now to find the volume in board feet is to figure out the total width of the boards. We can do that by laying them down side by side. So the total volume of these boards is 8.5 board feet.
But Bob, you have to figure all that out without cutting the wood.
That's all figured out for us in this main log rule. I know that this log is 10 feet long, and then I measure the width of the log, which is 12 inches. Then I come down to where there's 10-foot length, and I come over to the 12 inches.
So the volume of wood in this log is 65 board feet?
That's correct.
Oh.
The main log rule is so handy, the answer it gives accounts for only the volume of usable wood in the log. It ignores the parts of the log that aren't usable, like the bark. So after Bob made the measurement, the log was sent to the sawmill where the actual cutting takes place. When the log was cut into usable boards, Bob's measurement turned out to be pretty close. The volume of usable wood in the log was 63.5 board feet. That's enough to make dog houses for 2 German Shepherds.
Tomorrow, I'll be back in Hollywood, where I'll be talking to super fashion designer and model Cheryl Fatigues. We'll see her new line of convertible swim and evening wear. Till then, this is Sybil Sawyer, and Broadway is my beat. Bye-bye.
Oops is brought to you by Erasers. Don't make a mistake without one. On January 19, 1924, Darrell Dunnis was arguably hard at work for the railroad company. Arguably, because his boss thought he was hardly working and Darrell Dunnis thought he was overworked. Nevertheless, Darrell made a simple mistake on a complex job. Because of that tiny mistake, just look what happened.
Oops. The answer should be about 12.
Let's look at that again.
If I had done it right the first time, maybe this wouldn't have happened.
Oops was brought to you by Erasers. Don't make a mistake without one. Oops was brought to you by Erasers. Don't make a mistake without.
Good day. In a news bulletin about to be handed to me, in the bizarre and sensational trial being held in city court today, the case against Arnold Tiefenthaler has taken an unusual turn. Here's Sean Diaz with the story.
Thank you. And to briefly recount the story, Arnold Tiefenthaler is being tried for mismaking a queen-size bed. 6 weeks ago, the king ordered a bed made for his wife, the queen. The king called Tiefenthaler to his chamber, for Arnold was the palace bed maker.
Well, Kingly One, how goes it? Oh, careful, sire. Just had those tuned. Listen, I got a memo here that you need a queen-size bed.
I don't need a queen-size bed. My wife needs a queen-size bed.
Oh, right, sire.
I have a king-size bed.
Well, I'm very happy for you, sire. Now, what dimensions would you like me to make said bed?
I had the queen lie on the floor, and I measured her with my feet.
It's very regal of you, sire.
The bed should be 7 feet long.
7 feet long.
7 and 4 feet wide.
And 4 feet wide. 7 by 4 feet wide. Got it.
Now, when may I have said bed?
Oh, quicker than you could say box spring, sire.
I appreciate that gesture.
Well, no problem. It's gesture, sire.
Gesture.
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 Gesture. Very good, sire.
The rest of the story you know. Tiefenthal returned with the bed, and it was indeed too small. The king, angered beyond words, had Tiefenthal brought to trial. As the prosecution began its case, things looked impossible for the humble bedmaker, because he admitted under oath that the bed he made was, in fact, too small. The district attorney accused Tiefenthal of trying to humiliate the king, and Arnold retaliated by saying that it would be nearly impossible to humiliate this particular king. Although the prosecution thought that its case had been proven, the jury found Tiefenthal not guilty, and he was freed. With me right now is his defense attorney, Eugene Beckler. Eugene!
Hello, Sean. You are probably about to ask me how I won the case for my client.
No, but I would like to know how you won the case for your client.
Well, Sean, what size bed did the king order from my client?
As I recall, he ordered a bed which was 7 feet long by 4 feet wide.
And I proved that's exactly what he got.
But the bed was too small.
And why, Sean, why was it too small? I'll tell you. The king measured the queen by stepping off the dimensions with his feet.
That's right.
My client measured the bed by stepping off the dimensions with his feet.
Correct.
Sean, I have here one plaster cast of my client's feet, and I have a plaster cast of the king's feet.
That's quite a feat.
Sean, please note, the king's feet are larger than my client's feet. Therefore, when my client made the bed 7 by 4, as prescribed by his feet, the bed would be indeed too small.
You are brilliant for a lawyer.
And Sean, for a television news person, you are adequate.
Oh, and here's the king. Excuse me, Your Highness. Could we have a few words with you, sire?
Sure, Sean. I love your show. It's great.
Thank you. Your Highness, are you glad this horrendous ordeal is over?
I certainly am, and I'm glad justice has been served.
No hard feelings, eh?
Now, when a few loads to do, but the queen is still a bit miffed.
Oh, why?
When she goes to bed at night, she has to stand. Take my queen, please. See you around the quad.
Cheer up, sire. This is Sean Diaz reporting.
You've already seen this much of Square One TV. How much do you figure is left?
Madman, your mission is to eat only multiples of 6. When you encounter a number, you will have until the count of 3 to make your decision. And beware the devious Mr. Glitch. He will eat you if you are wrong.
Mathman, 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 Mathman. There's one now. Mathman, Mathman, Mathman. Multiples of 6. Mathman, 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 Mathman. I think so. Woe is me. Mathman, Mathman, Math.
You're it.
Feel the beat and it makes you wanna get up off your feet. Your body's counting and your feet just gotta move.
Can you hear every bar is for a beat that you can't self-divide? A simple matter of fact, we all know how.
I never thought or realized
it'd be so cool to subdivide.
The time is right.
Let's twist and shout.
Let's have some fun.
Let's shout it out. Shouting out the rhythm. 1, 2, 3, 4. Shouting out the rhythm. 1 and 2 and 3 and 4 and grooving on the rhythm. 1 and a 2 and a 3 and a 4 and a. Now he's got the groove just right. We can subdivide and dance all night. in the groove that makes you want to move. It's a secret you can share with all your friends. Remember that every bar has 4 beats that you can subdivide. It's a simple matter of math. Let's show 'em how. I never thought I'd realize it'd be so cool to subdivide. The time is right. Let's twist and shout. Let's have some fun. Let's count it out. Counting out the rhythm. 1, 2, 3, 4. Shouting out the rhythm. 1 and 2 and 3 and 4 and grooving on the rhythm. 1 and a 2 and a 3 and a 4 and a now we've got the groove just right. We can subdivide and dance all night. Counting out the rhythm. 1, 2, 3, 4. Shouting out the rhythm. 1 and 2 and 3 and 4 and grooving on the rhythm. 1 and a 2 and a 3 and a 4 and a now we've got the groove just right. We can subdivide and dance all night. Counting out the rhythm. 1, 2, 3, 4. Shouting out the rhythm.
And now it's time for one of America's newest game shows, But Who's Adding? And here is the host who loves numbers the most, Larry Cedar.
Hello there, how you doing? Welcome everybody, and out there in Additionland, welcome to But Who's Adding? Let's bring up our first 2 contestants and get going here. Now, give them a big hand. Here they are. Playing blue today is
Laura.
Laura. How you feeling today?
Good.
You ready to do some good adding?
Yep.
All right. And playing red today is
Freddie.
Freddie, how you doing?
Fine.
All right, it's gonna be a tough game, huh? You ready? All right, let's turn around and take out the rules of the game. This is the big board up here. Now, the object of the game is to cover 3 squares in a row with your color, either horizontally, vertically, or diagonally. Now, the numbers on the big board represent the sum you get when you add 2 numbers from the addend board together. For example, if there's a ring on the 4 and there's a ring on the 5, you can cover a 9. There it goes, just like that. Now, the player who goes first gets to move both rings and announce his or her score. After that, the next player moves their color ring only anywhere on the addend board. Now, you have 10 seconds to move your ring and call out your answer. If you don't do it in 10 seconds, you'll hear this. Means you ran out of time. If you call out the wrong sum or you call out a sum that's already been covered on the board, you'll hear this. Means you made a mistake. Now, if you run out of time or make one of those mistakes, you'll lose your turn and your opponent gets to move both rings. Now, the first player to win 2 rounds wins the game. Red goes first. You guys excited? Here we go. And cheer them on, folks. Red, go. 11 red. 14 blue. 12 red. 7 blue. 10 red. 9 blue. 3 red. Oh! All right. Yeah. All right. Tough competition. Maybe Laura's going to make a comeback now because, Laura, you lost. You get to go first on the second round. Freddie, you've got 1 round. If you win the next one, you win. If Laura wins, we tie it up. Okay, blue, go. 14 blue. 13 red. 11 blue. 6 red. 3 blue. 8 red. Oh, yeah. All right. Looks like red team, you got a winner here. Freddie, congratulations. You won. You got 2 rounds. And for winning, you get a Square One TV calculator. Have fun with that. Laura, you did a sensational job, and I think you guys were very, very close here. And for just playing along here, you get a Square One TV t-shirt, and I want you to enjoy that. You were both great. You were a sensational audience. Thanks a lot. We'll see you next time on But Who's Adding? Take care.
The story you are about to see is a fib, but it's short. The names have been made up, but the problems are real.
It was Thursday, 2:43 p.m., and it was over 110 degrees in Sri Lanka. Luckily, we were working MathNet out of Los Angeles. My partner is George Franklin. The boss is Thad Green, Chief of Detectives. My name is Monday. I'm a mathematician. We had been working on the problem of the missing baseball and had gone down one blind alley after another. Still no solutions. Just have to keep at it. We decided to look at the last scene from yesterday's show to see if there was anything we had missed.
Notice something strange, George?
Yeah. All the numbers on this side of the street are even, and 727's an odd number. No problem. Just means the place we're looking for is on the other side of the street.
Have you looked on the other side of the street, George? There are no odd-numbered houses on Bluff Drive. The address is a phony.
We're still working on it, Howie.
Can I do anything to help?
Not yet, son, but if we think of something, we'll call you.
My dad will be home tomorrow.
We know, Howie. We're doing everything we can.
I hope it's enough.
Son?
If I don't get that baseball back, he'll tar and feather me.
Uh-huh.
He'll put me in the stocks.
We're trying.
Probably run me out of town on a rail.
Goodbye, Howie. Did you run a make on Clarence Sampson?
Uh-huh. It's amazing what we can do with these computers, isn't it, Kate? I remember when we had to do it by hand. It took weeks. He goes by a lot of aliases. Charles Charlie Sampson, alias Carl Sampson, that's with a C, alias William Howard Taft Sampson.
What have you got on him?
Spent 13 years in state prison for robbery. Paroled 6 months ago.
Uh-huh. What kind of robbery?
Gold bars. They took 10 of them in 1975. Know what they were worth?
Nope.
Well, according to this, a gold bar weighs 330 ounces.
Uh-huh.
And gold was worth $160 an ounce back then.
Let's see. 330 is about 1/3 of 1,000. 1/3 of 160 is 53. So each gold bar was worth $53,000.
So 10 bars at $53,000 each, he got away with more than $500,000. Probably worth a lot more today. The gold bars, I mean.
Uh-huh. And they never found the gold?
Nope. You know how he did it? Swiped the gold, I mean?
How?
Took it out of the top of Fort Knox. Well, you know, Kentucky, the bluegrass state.
Out of the top. How did he do that?
Helicopter.
We needed more information. I asked Jenny to check the specs on the XY313. George was checking some house moving companies to get an approximate weight on Mrs. McGregor's house.
Thank you very much, sir. I've got some info on the XY313. It's got a range of 600 miles.
It's a lot of range.
How's that?
Look. The missing baseball was here in Burbank.
You mean the house?
Yes, but as George says,
You got the house, you got the ball. Uh-huh. Go on.
Look, on this map, 1 inch equals 20 miles. So for 600 miles, we would measure 30 inches, which would take us all the way up to Oregon.
So the house could be almost anywhere.
But the helicopter's range is 600 miles. It would have to fly back to base after dropping off the house, so it couldn't have flown more than 300 miles each way. But that would still take us all the way up to here.
That's still too much ground to cover.
Jenny, Kate, I got an approximate weight on the house. The moving company said it weighs about 7 tons.
14,000 pounds.
The XY313 can handle that. It could carry up to 16,000 pounds, but the 600-mile circle is still too big.
Wait, we're forgetting something.
I know, Martha told me. Green peppers for the meatloaf. You sure you can't come, Jenny?
Positive.
Kate?
Uh-uh.
You guys ever had Martha's meatloaf?
Yep. What we're forgetting is that the helicopter was carrying a house. Now, that extra weight would cut the range back even further. But how much?
Yes, sir, me again. I was wondering if there was any way you can tell me how far the helicopter flew. You can? Uh-huh. Okay. Oh, I see. Thank you.
Got something?
Blackboard. He said he refueled the tank this morning. It used 2,400 pounds of fuel. At top speed, it burns about 4,800 pounds per hour.
2,400 divided by 4,800 equals 1/2. That means it was up in the air about half an hour.
Right.
What kind of speed does it make?
The XY313 has a top speed of 160 miles per hour.
So in a half an hour, it would have flown half that far, or 80 miles.
He flew someplace and returned to the base.
That's right. We take 80, divide it by 2, and we get a radius of 40 miles.
We can cover that. 40 miles, I mean.
Let's take a look at that other map. On this map, 1 inch equals 5 miles. So 8 inches equals 40 miles. This is the helicopter base, so the house could have been dropped anywhere within this circle.
But look, 20% of that circle is Pacific Ocean. We can eliminate that area.
Uh-huh.
They wouldn't have put it there.
Right.
It would sink.
All we have to do is concentrate our efforts in this area, but it's still going to take time, and we need that baseball by tomorrow.
Wait a minute, we're forgetting something else. A helicopter would make a lot of noise carrying a house. Let's question some of the residents in the area and see if they heard anything.
That's going to take time.
Got an idea. Hello, Howie? No, it's not your father. I asked Howie and his friends to ask people all over the area if they heard or saw a helicopter on the night the house was snatched. They began to call in with their reports. Uh-huh. And no one saw anything, but a couple of people thought they heard a chopper. Uh-huh. What's that? Nothing unusual except what? Television reception on the Fritz. Thanks, Howie.
Anything, Kate?
Some people complaining about their television reception that night.
Funny, so was the guy we talked to.
What guy?
The guy in Tuesday's episode, remember? He complained about his TV reception, too.
MathNet Monday. Hello, Nell. Find out anything? Some complaints? TV reception. Are you in the Whitechapel area? Thanks. George. Those complaints are all coming from the same direction.
MapNet. Yes, Mr. Bigger. More complaints about TV reception? What area? Thanks. Same direction, but further southeast.
And it must have been the helicopter that was causing that interference. Look, it's giving us an arrow. The house has to be somewhere along this line. What we've got to figure out is where that interference stopped. Call Howie. George called Howie and told him to follow the arrow until he ran out of interference complaints. I checked the map.
I'll get it. It's probably Martha. Sure you can't come, Kate? She'll be awful disappointed.
Uh-uh.
MapNet. Oh, hi, Howie. I thought you were my wife. Really? The complaints stop at Scenario Circle? Nothing beyond that point? Terrific, Howie. The house has got to be here.
We've got our man, George. Let's roll.
Well, let me tell you something, Alfie boy. You are much smarter than you look.
Thanks, Throckmorton.
Yeah, but then again, who isn't smarter than you look?
Yes, sir, I wonder if you've ever seen this.
I can't see a thing without my glasses.
100% of Square One TV is a production of the Children's Television Workshop. This program was made possible by grants from the National Science Foundation, the U.S. Department of Education, the Corporation for Public Broadcasting, the Andrew W. Mellon Foundation, and the